obviously, with Nick, but does everyone else want to give a quick introduction, please?
Hi, I'm David Mihal. This is my third panel of the day, so some of you guys might know me. I'm a senior architect at Fuel Labs.
Hi, I'm Marcin. I'm software engineer, chief protocol architect at Matter Labs. We're working on zkSync.
I'm Ellie. I work at Espresso. I lead our consensus team and also do a little bit of research and development there.
I'm Nick, the CEO of Fuel, and I do too much and not necessarily as well as I'd like. Yeah.
Always humble.
Okay, cool. So the topic is solving fragmentation. How would you describe what that actually means? What does fragmentation mean comparing to a monolithic architecture?
I look at it as, for most of the existence of crypto, especially most of my time in crypto, the main problem we've been trying to address is scalability. Like this is, since the Bitcoin Lightning days with CryptoKitties, all this, like it's always been how do we scale blockchains? And at this point, like we kind of did it. We kind of figured it out. I mean, we're not completely done, but theoretically, like we've scaled blockchains. By doing it, we've introduced all this fragmentation. There's like, 30 different rollups now. They all kind of feel like individual. They don't feel like they're all part of Ethereum. They all feel like their own individual world. So I'd say interoperability is like, it's the next problem, and it's taking all these isolated chains and reuniting the Ethereum family again.
I would disagree. I don't think we solved the scalability problem. It's still like transactions are expensive. There are limits the moment. I think all of you have seen Inscription Fun. That's where we've seen the maximum limits of what chains can do. So I think there's still plenty of work needed to be done before we can say that scalability is solved up to the level where people don't care. Like for me, scalability is solved when people don't have to care about the cost of the transactions. Same way you don't care about you going to Google, how much the cost of the Google query is, but you still do when you do it on Ethereum. So we're still not there yet.
Would you say scalability is solved in theory? Because certainly, like using a blockchain, scalability is not solved, but that we have through zero knowledge, through rollups, DA scaling, like we've got like the pieces to solve scalability.
Yeah, but we have a bunch of work ahead of us.
For sure.
So don't rest on your laurels. Please keep working.
Fair enough.
He's not resting on his laurels, I know for a fact. Yeah.
Okay, good.
Oh, well, I guess going back to the question, yeah. So solving fragmentation to me is, mainly around interoperability, but I think there's kind of two ways. I think it's about interoperability that's invisible to the user specifically, because I think right now we have a lot of interoperability, and if you want to be a really sophisticated user, you can get interop, but truly it's like making it invisible to the user where they don't know what chain they're transacting on, it's just a very smooth UX.
Yeah, I think with fragmentation, Dave, I think you gave a great answer, which is effectively we've started to build different layers and different ways to build off of Ethereum and build off of existing blockchains. And again, it's opened up an incredible amount of creativity, an incredible amount of expressiveness, and how we can solve infrastructure issues. But at the same time, it's been very difficult for users and devs to live with this reality because everything's in different silos, everything's in different places. They use potentially different virtual machines, different forms of finality, different kinds of systems to basically make all of this work. And right now it just feels like maybe how the very early internet felt when you would go to different websites and they were just completely isolated little worlds, and they would never ever interoperate with each other. They were just one little page here and there. And I think we're getting to a point now where we're like, okay, so maybe some of us have the right ideas, we can solve some of these problems, but for a user, how can we make that feel and be something that they don't even notice anymore? That it doesn't matter what chain you're on, what environment you're on, it will just work, yeah.
But it kind of should matter because different chains give different guarantees. And if you try to hide it, then users might be, users then may end up in a situation where they thought it's secure, they thought there's I am fully secured by Ethereum, but oh, actually you are on DA and this DA didn't fully work, so sorry, your data is lost, right?
Yeah, I think that's a good point. I think there's different levels of users, and I think a lot of transactions probably, don't really care. But I think for some transactions, especially more sophisticated ones, yes, I think that users should be able to do it. I think that this is a place where wallets can actually be really powerful. Is wallets can kind of choose for users that don't know. I think it's difficult to explain to users all of the different trust models we have out here. So maybe that's where like a really smart wallet can come in and say, hey, you're doing a really expensive transaction. Maybe you should be doing it on like this trust model. Or, oh, hey, you're doing just like a gaming chain. Maybe you don't need full Ethereum consensus. So I'll route you to this one for you. That's kind of the future I see.
I agree 100%. I've seen this chart on a talk this week, and on the left-hand side, you had security. On the right-hand side, you had more of these like real-world use cases that we're trying to do high throughput with gaming and social, where the security is lower on the right side, and kind of I think that's exactly where we're headed as well.
So one thing I would say is that hopefully it will be similar to how HTTPS works in the internet. Example being, if you remember back in the day, only like serious banks were using HTTPS, right? Everybody else was like, yeah, just HTTP because HTTPS is too expensive. There's like all the setups, whatnot. Now everyone uses HTTPS. And I hope that we're going to get to such a place that all the chains will be secure enough.
I agree.
That we're actually going to start using things like zero knowledge rather than optimistics, so that everything will be enough secure that, like HTTPS, that everything will be by default and people will not have to have this choice.
I think the thing is we can't expect users to understand the complexities of all these different security properties and their DA layers and stuff. Just like users, don't really need to understand like the SSL certificates and stuff of their website.
They don't?
My mom doesn't. So there's like I think different parts of the stack where actually the security will matter. It's not usually the end user, but you mentioned wallets. Like that's certainly a place where your wallet can kind of let you know, like, hey, maybe there's some risk associated with what you're interacting with. Certainly application developers will be the one that say like, hey, I'm building a game. I'm willing to make some compromises on DA or something, or I'm building a DeFi application that I want really large amounts of capital, so I want like, a full Ethereum level security. And when it comes to things like interoperability, I think what becomes really interesting is when you're bridging all these different security models and any protocol that's spanning different security models, there's going to have to be some sort of marketplace or some way of pricing in the different risk. And I think that's the real way to solve that is let the market say like, hey, if you're bringing assets between chains that have different security properties, what is the price of that? What's the cost associated with those different environments?
So I think, like you mentioned earlier, that we, in theory, have solved the scalability issue in terms of we know what to do. People are building and executing. We're improving both vertically and horizontally. But in terms of the actual like roll-up infrastructure that we're starting to see play out at this point, what would you say are some of the biggest challenges in terms of building in this manner that that you've kind of seen in your experience so far?
I mean, I can go first.
Yeah, go ahead.
Yeah, I think there's many things. I think that, well, for one, while we can do interesting things and interesting new things, it's also very painful and very hard to do new things and do different things. So for us, we have a different virtual machine than Ethereum by choice. We have a different language than Ethereum by choice. And we do so for various motivations and various reasons. And so for us, while it's really great that we can do this, we really can do a completely different machine, a completely different architecture, and solve problems in very different ways, it's a big challenge to move developers over to our stuff. It's a big challenge for us to want to go through the pain of doing all of that in the first place. It would have been really easy for me to just, do an EVM roll-up and like call it, but we didn't want to do that. No, it's not that bad. Unfortunately, I know the EVM too well, and I wish I didn't. So for me, I think, at this stage, we chose a harder path, but I think it's a more interesting path, at least for us. But I'm very excited about all the different architectures that are coming, and I think the pain is worth it. And I think the challenges are really exciting, and they're ones I think many people want to join you in trying to experiment with and see what's possible basically.
Yeah, so I guess on my side, even though I spend most of my time working on consensus, I think one of the things that's been the most difficult is dealing with the economic incentives. So obviously it's great for users to have interoperability, but when you're talking about rollups, like so Espresso is building kind of this shared sequencer, or actually it's a marketplace kind of for a shared sequencer, but it's very difficult because you say, hey, rollup A, you should interop with rollup B, but rollup A and B don't want to give up their revenue, that they get from sequencing fees. And so I think that that's a really difficult problem. At Espresso, we have a solution where we're working on like this auction design where rollups will get refunded their MEV, which is pretty cool. But yeah, I just think the economic incentives of like rollups to actually be interoperable is still a really open question.
So I think this will happen similar things. Let's say if we look at the history of internet, think about something like emails. If there's a critical mass, there's going to be a critical mass of rollups that have interop, then others will join. But right now we're in this situation where like everybody's holding their card tight because the first two that will start collaborating, each one of them is going to give up something, right? So kind of we're in this like prisoner dilemma game where for now the optimal move is to keep your cards close. But at one moment, I think that some of the rollups, when the whole discussion and fighting will commence, some of the rollups will decide to like team up, and then hopefully we'll end up with a nice interop sometime in the future. Or it will be a slaughter and the good comparison here is, let's say, email, that you can send email to anybody versus, let's say, chat apps like WhatsApp, whatnot, that are completely not interoperable, right? So that's one of the two worlds we're going to end up with.
Okay, so you are working on with Espresso, so decentralized sequencer network. I'm just kind of personally curious, what types of demand have you been seeing for that, and what are the types of customers that you've been talking to, and what are they currently using? Like, what type of architecture do they currently have?
Yeah, so I mean, our customers are rollups, and we see a lot of different kind of rollups. So on one hand, we kind of see rollups that are more like on maybe like the gaming side, where they want something that's faster than Ethereum, which Espresso can offer. But on the other hand, I think we also see rollups that are very interested in interoperability, specifically like cross-chain arbitrage. Maybe they have a lot of demand for that. So right now, pretty much all of those, they're either running on a centralized sequencer, or a lot of them actually haven't even launched yet. They're new rollups that are coming into the space that want to start with a decentralized sequencer. But yeah, it's rollups, a lot of rollups that are really interested. Yeah.
Okay, so one of the biggest challenges in this type of architecture has to do with liquidity, and also if you have a world where we're starting to see hundreds or even thousands of rollups, then you might also consider how all of these are going to be interacting with like DeFi protocols and things like that. So I'm just curious, like what does the world look like where we do have thousands of rollups? Where do oracles fit in an ideal world? How do we solve the liquidity challenges as well?
So I have a few opinions on this, although I'm sure others do as well. So I think that there's kind of two parts to it. So the first part is that you need like atomicity. So you can if you can have an atomic transaction between any two rollup, then you kind of solve this liquidity problem, because you can say, hey, let me transfer funds over to this other rollup, do some transaction, and then like put it back, which is really, really great. And so that's kind of what like a shared sequencer provides, like Espresso. And that's the first step, and it's a required step. I think then the next step is you want to do that trustlessly, which means that you want to be able to do that, that interop between rollups, but you want to do it using some sort of a proof where one rollup doesn't have to trust another rollup, or where the user doesn't have to trust someone that they're promising it's going to execute. So I think that's the second challenge, and that will probably take a little bit longer to come.
The second thing is it's called zk proofs.
Well, I think it's better when the zk proofs could be more real time.
There's a lot of subtleties to that,
Yeah.
And I'm slapping a warning label on that.
Why?
I just can, No, because I think that, so for me, first of all, I love zk stuff, and we use it in our stuff all the time, and as well, we're very excited to use all the zk that zkSync produces, and that all these different teams produce. We had Bobbin here, works with Maiden, and I love Maiden, and I love Bobbin too. We talk about different designs all the time. The main issue is that, at least for us, I think, there's lots of different forms of trust going on, and a lot of different forms of truth going on within the different chains right now. And zkSync will produce their form of truth with a zk proof. We will produce our form of truth with an optimistic rollup. And basically, we can bicker and argue about how one is better or worse, but the point is they're different forms of truth. The market will interpret basically what that value is. And I think the issue now is basically that we have these different architectures. Eventually, Fuel will be all zk. We will go 100% into the zk space, but not right now. And so in the meantime, me and potentially others as well have a sort of interesting dilemma in our hands, which is that we want to see fragmentation solved, and we want to see these liquidity problems solved such that for a user, they can interoperate with all of these things. But how we prove that, how we approach truth, and how we approach finality, and how we approach risk, and the way that the market wants to approach it, is a more complicated question, because they'll all exist, whether we like it or not. zk or optimistic rollups will exist for quite some time. And I think that as we kind of venture into this new world, I like the idea of more and more integrating zk to resolve some of these issues. But at the same time, I'm also, for me, in building an architecture that's incredibly high throughput, I'm still not convinced yet about the proving times, but I know that everyone seems to tell me that it's going to be solved. So when it does, we'll be very excited to move over. But until then, we like having the optionality. But yeah, I think hopefully that gives you guys a bit of a sense of the hesitation and also the problem that we're currently dealing with.
Yeah, if I could add to that, like I'm very, very bullish on like zk proofs, and I think that that's how you get trustlessness, and it's really important. I think that there's a difference though between like synchronous composability and asynchronous composability, and you can't do synchronous composability right now with zk proofs. It just takes too long. I'm actually curious to know what your thoughts are that there's a lot of different proving schemes, and do you expect like every project to kind of consolidate on one scheme so we can like prove everything together? Or to me, it seems like we're always going to have these different proving schemes out there for different projects.
Yeah, there will be different proving schemes, and I think that, but at the end of the day, it will end up with like 2 or 3 with a little bit different trade-offs.
Okay.
There's usually this spectrum of, how big is your proof versus how expensive it is to create versus how expensive it is to verify, and depending on where you verify, there are like the trade-offs. I do not foresee like hundreds of them being done. So yeah, I think we're going to end up on just few.
Yeah, well, I think that poses an interesting question, because if you have 2 rollups that have 2 different proving schemes and you want them to interop, you can't necessarily. It's a little bit more difficult to do a proof together.
No, it's actually quite easy. It's just a matter of making sure that they have verifiers from each other. Like it's a piece of code that will verify the other proof.
So yes, they each have their own verifier of each other. Yes, you're right.
And if you stayed around for my finality gadget presentation before that I did, there's a very interesting mechanism that I'm waiting for zkSync to break that basically would allow you to, in an optimistic sense, get very fast forms of finality. It's a form of finality. I'm not going to say it's zk computation, but I'm going to say that for many, many use cases, I believe it's enough to be able to do the kinds of bridging and the kinds of finality that we need right now for very high throughput environments. But I'll say that an interesting thing, and especially that Bobbin brought up from MindVM today, is that I also think there's something in the middle here, which I think you were trying to bring up before, Nader, which is that it might be the case that a lot of the time we want to go down to a really finite version of settlement, but maybe users are fine taking a bit of a risk or a bit of a leap, and maybe that has different trade-offs for a moment or for a short window of time, but then the user is brought back down to something safer again once they leave that space. And so, I think this is really like an interesting property that you can design internally in a system, or you can have like across the space. And I feel like we'll see this more and more because, for example, like it's really great to come down to finality in a zk system. But maybe if I want to step out to something that's doing millions of TPS a second, maybe I can enter that world for a minute and then come back down to something else, right? And I think there's going to be different mixtures in the market. And I also feel like systems like Espresso too, and blending some of these things together or allowing people to interoperate them is going to be a very interesting challenge, but it is a very exciting challenge because the creative landscape here is very enormous. There's so much we can do. So, yeah.
I'm not sure how much time we have left, maybe 5 minutes or if it's longer than that, but I'm going to continue on, and then I have other questions if we don't have to stop. But one of the things that is a huge value proposition of a monolithic architecture has to do with composability. So you have developers building, you have liquidity there, you have successful applications that people can build on top of, and you kind of have this vibrant developer ecosystem that comes out of a large user base, not only of actual users, but developers. And that's one of the criticisms of this form of architecture, where you have these app chains and application-specific rollups. So, and I know that like maybe what you all are building is going to be launching more of a shared network, but I think ultimately like that's where a lot of of these networks are headed. So, what are some of the ways that that can be solved and that question can be addressed?
I mean, I think it's clear that we're going to be moving from a world where everything, like on layer 1 Ethereum, we have this really nice synchronous composability of everything, and it's super fun, but of course it just doesn't scale at all. It's going to be like a rough transition to a world of largely asynchronous composability. Some applications will still need synchronous composability. They'll co-locate on the same, the same rollup, the same execution environment. But this is something we've been through before. That reminds me of like the move from single core processors to multi-core processors. Everyone was used to every year your CPU just gets faster, and then at some point the CPU stopped getting faster, and it's like, well, now you just have 4 CPUs instead of 1. So go figure out how to take advantage of all 4 of those. So we're gonna have to figure out how to like build applications that can be asynchronously composable. That's gonna need lots of dev tooling. It's gonna need tooling, and it'll be a rough transition, but that's clearly the only way that we can scale these things.
I agree, and this will require app developers to actually stop staying in the comfort of EVM and being like, yeah, it's all gonna nicely run, and go into this crazy world of, darn, there's like async, and what happens when async doesn't return, etc., etc. So they will be scared. I know that, but over time this will be fixed. In the meantime, what the composability, I guess it will still exist in this async mode, where like you would have these quasi bridges, and some of this might be moved to the user side, some of this might be moved to the wallets. That wallets will be like responsible for like trigger this and then carry this on the other side, etc., etc. Therefore, the final users would still feel that kind of things happen, but wallet will be responsible for carrying things over. So we'll see. For sure, it will be exciting world. So.
Yeah, I would say that I think, Dave, your analogy is excellent. It's basically, we used to build things in very simple single-threaded computers. Theoretically, we knew there could be other ways to thread these processes, to do different assignments of different work to different computers, and then bring that into some kind of synchronous sort of experience, right? Or some kind of synchronous output. But even at one point, that was like theory. It wasn't actually happening. And it probably seemed crazy to a lot of people doing it, that like we might even venture into that space. I think with blockchains, very similarly, the same kind of thing is happening. How the sort of, you could say, cross-thread communication of the messaging will work is an interesting problem. But at this point, there's way too many smart people around this community to solve these things. It'll get solved. It's fine. And in fact, even if it doesn't, like quite frankly, outright, to be fully synchronous, for example, it's still pretty great, still pretty amazing. And you can create experiences that would be so close to being synchronous, it wouldn't make any difference to a user, like waiting a few extra blocks or a few extra ticks of approving until things actually happen. It's like, who gives a shit at that point? You've accomplished the end goal. And the end goal is, I want to do X, and X gets done. However it gets done will be abstracted away from the user. Yeah.
Okay, to wrap this up, what is everyone's favorite team or protocol that's doing something to solve fragmentation?
Well, okay, I'm obviously outside Espresso, because Espresso is working on this. But I actually think that the ag layer from Polygon, if you guys are familiar, is really neat. I think it's actually very complementary to shared sequencing, but I think it really combines this like trustless interoperability, and I think that that's a really cool project.
I think one area that's interesting, we're seeing kind of different parts of the stack that are needed for interoperability, shared sequencing obviously being one, and state proofs seems like kind of an interesting direction. There's a number of different projects exploring state proofs. That's like super useful for proving. And I guess one other thing I'll add is I'm sure you guys have been working a lot with. I think everyone of us has been working with Justin Drake, who's trying to like cat herd all the various teams in the space into some kind of alignment and bringing interoperability to the whole like Ethereum space. So yeah, respect the work that he's doing.
So I think nothing is there yet. Like nothing is there that's actually popular. Yes, we start talking. We hear about like aggregation layer, shared sequencing, etc. But these are like still like at the fringes. We still don't have the email equivalent that just works, right? So hopefully something like this will show up over the next couple of years. Or as I said, we're gonna end up in the current chat setup where everybody will be living in their own world and sharing will happen through like, oh, I send it to on Signal. No, on WhatsApp. Well, no, somewhere else.
Like I think in terms, if I had to pick one, I think the one that at least captures. Okay, I was gonna say Espresso. I was, and I like Espresso a lot. I think there's a lot of cool ideas. But I'll, in this case, just to get a shout out in there, I'll shout out Josh Bowen and Astria. I think he also has a lot of really unique ideas about how the cross-chain composability will work and shared sequencing. And I think that it doesn't get enough attention. Obviously, Justin Drake gets a little more attention, and Espresso as well. But I think all these things are really interesting because they're trying to answer these bigger questions of how this is going to work together. It's easy for the different rollups to solve it within our own ecosystems because we'll all have our own solutions. Fuel will have its own, zkSync will have its own. That's not hard. We can design for that, but it's much harder to design between Fuel and zkSync, for example, if we're going to pick different forms of truth as our end state. So I'm very grateful there's other shared sequences around that are thinking of these things and how this might work. Yeah.
All right, I think that wraps it up. So thank you for being on the panel, and thanks everyone for hanging out.
Thanks everyone.
Thank you.